All right, so welcome to our first video on our statistics unit for Algebra 2. I want to give you guys some overview of some vocabulary words and just some talking through a few different things just to make sure that you understood this and got these from the activities that we did. So the first one is, what is the difference between a population and a sample? And so when you're a statistician, you think to yourself, hey, I would like to know what teenagers in the US think about this particular topic. Well, I can't go ask every teenager in the US a particular question. That would be impossible because that's like so many people and it would be expensive, it would be difficult, it would be time consuming. So I can't possibly ask every single person that question. And so instead what I do is I pick a sample. Maybe I'm going to ask 100 teenagers what they think about this issue. And then I'm going to kind of say, hey, if it's true for 100 teenagers, it's probably true for all of them. Now, there's some rules and things about that to be able to do that properly, but that's the gist of this. So a population is going to be the whole group that you want to study. And everybody in it, okay? So if I'm talking about things like people, teenagers, it would be the whole group of teenagers in the US. And then my sample is going to be the small group that I ask questions to, okay? This can work for anything, not just people. So it could be that I'm curious about the size of hummingbirds in Texas, okay? Now, that's not the size of hummingbirds everywhere. I'm only curious about Texas hummingbirds. And so my sample is going to be 50 hummingbirds in Texas that I find, okay? Maybe I'm curious about, let's see, I'm trying to think. I should have thought of examples before I started. M&Ms. Right? They make M&Ms and M&Ms are a particular size, right? They're a certain number of millimeters across. Is that true of every M&M in the planet? I can't possibly check every M&M in the planet. So I'm going to buy 3 bags and I'm going to figure out what the size of those are and assume that that's generally how they all are. Okay? So population, the whole group, sample is what I pick from. All right, got to move that out of the way. There we go. Okay, ways to describe a distribution. So we describe distributions on different characteristics: shape, center, and spread. And so we're going to start by talking about shape first. And so we have different vocabulary words we use for each of these different shapes. So this shape is pretty much the same across the board. It's like everything has an equal chance of being selected. We call this a uniform distribution. This one, if I think about it, I could draw a line right down the center and it's roughly the same on this side as it is on this side. So I would call this one roughly symmetric. And I say roughly because I know my picture is pretty good, but real data in the real world is not always so beautiful. So we usually say it's roughly symmetric, okay? We can also say that, well, you know what? There's a lot more higher answers here than lower answers. And so we say that these two are skewed. When we describe something as skewed, we also give it a direction, right or left. This would be left skewed. This one would be right skewed. And one way that you can remember that, we're all in Colorado, right? And so think about the direction that a skier is going there. This is me skiing. Okay, see, I'm happy. My ponytail is blowing in the wind. Okay, I am skiing to the left, and that's how I know that this is skewed left. This one, I would be skiing towards the right, so this is skewed right. One more picture that I'm going to draw here for you is what we call the normal distribution. Okay, a normal distribution is symmetric, but it's also bell-shaped. And so when I draw this, I draw it like a bell. It has its center and then it goes off in both directions. This one would be a normal distribution. It is symmetric, but it's also bell-shaped. Okay, let's look at our next one. So we've described the distribution with shape. We are also going to describe it with the center. Now, if it is a roughly normal, roughly symmetric, we are going to use the mean. If it is skewed, we're going to talk about that later, or maybe we don't even get to it in this class. I don't remember, but for our purposes right now, we are going to use the mean. Now, remember we talked about population versus sample. The population mean, we use population mean, we use the Greek letter mu to describe it. You could write it as mu. You could write it with the fancy M. My fancy M is terrible today. This is more like it, okay? So if we're talking about the true average of every teenager in the US's average amount of screen time, we would say that that is the population mean. But if I took a sample of 100 teenagers, my sample mean, I label something different. I call it X bar. And the way that I write it is like this. Okay, so that's why it's important to know, are we talking about the population? Are we talking about the mean, the true mean, the mu? Or are we talking about the sample mean, which is our X bar? Okay, you can compare different distributions. So if you have a distribution here, and then you have a distribution here, right? You can think of things where that might be different from each other. So for example, the heights of men tend to be higher than the heights of women. And so maybe this is the average heights of men in the population, and this is the heights of women in the population. Now, I can't say that every woman is taller than every man is taller than every man. There's overlap there, and this is probably not even drawn particularly well. They're much closer together. But what I can say is that the average population of each of these, one of them is higher than the other, okay? And let's talk about our third category, which is variability. Now, for our population variability, for both, we're going to use a measure called standard deviation. Standard deviation. Okay, and that's just how far away from the mean is the data. Okay, so you can see in this one, the data is pretty close to the mean, right? It doesn't have a big spread. This one, the data is more spread out from the mean. So this one has a larger standard deviation than this one, okay? This one is the larger one. This one is the smaller one. Larger, smaller. Okay, and we have symbols for this population standard deviation as well. The symbol sigma is what we use for the population standard deviation. For our sample standard deviation, we just use the letter S. Okay, and then again, we can compare. We can say things like the standard deviation of this is smaller than the standard deviation of that. Okay, we'll see some examples. And then the last thing I wanted to talk to you guys real quick is about frequency versus relative frequency. And I'm actually going to pull over the answer key to one of the questions that we did so that if you struggled on that, you can check your answers. Here it is. Okay. Frequency just means like the actual number, okay? So this particular was a phone company and their battery lives, and they said, okay, one phone lasted between 8 and 8.5 hours. 30 phones actually lasted between 9.5 and 10 hours. They tested 100 phones, and so that means that for each of these numbers, they said, okay, this relative frequency is just the percent or the decimal. So like 1 divided by 100 is 0.01. 2 divided by 100 is 0.02. 17 divided by 100 is 0.17. Okay, so frequency is the actual count. Okay, relative frequency is the count, like the actual count, divided by the total in the sample. Okay, so like 1 divided by 100 or 17 divided by 100. That's the only difference between frequency and relative frequency. It helps to kind of tell, like, especially if you were going to make a pie chart, right? You would want those percentages. So this is like my 1%. This would be a bigger percent, like 30%. Or a relative frequency is written as just a decimal. So 1%, you can write it either way. I prefer thinking of it as a decimal, but I know a lot of students think in percent terms. Okay, so that is that. Let me know if you have questions.